see he has a lot of breadth and a lot of depth in this particular subject area. And most importantly, I just love the energy and passion he brings to the topic. So please welcome Ed Hightower.
He said he would surprise me with something, so that was the Chinese Institute of Electronics that I spoke at. So, welcome everybody. This is the inaugural event for the Tech Titans IoT Forum Speaker Series. So I appreciate you guys coming today. And I've been speaking on the Internet of Things, particularly low power WANs, for the last 3 years. The IEEE Communications Vehicle Technology Director asked me to speak to their group 3 years ago. That started me on speaking engagements every year. And I keep up with what's going on in this area. But Sunil asked me, he said, come in and speak about low power WANs, but throw in something about smart cities. Well, when I started looking into smart cities, I was blown away. I knew the Internet of Things in general is going to be big. I did not realize just the segment of smart cities blew me away with all the activity, initiatives, and money that's going to be invested in that part of it. We'll get into that more in a moment, but it's exciting times. So what I'm going to cover today, I got 45 minutes, and then we'll have question and answer at the end of that. And I will be staying afterwards if you guys have any questions. I don't have another engagement afterwards, so glad to stay as long as necessary. I'm recording this now. If everything works out, then I will be able to edit and by this weekend hopefully post it. And you'll be able to see it on my profile. It'll be on the Tech Titans website eventually. So you can go back and review, or people that didn't get to see it are welcome to see it in the future. Today, I'm going to cover just a brief history of machine-to-machine, how it's evolved into the Internet of Things. I break down the Internet of Things into 3 components: the devices, the endpoints, the objects, whatever's in the field, nodes, different terms for it. I call it devices. Then the connectivity, typically that's going to be wireless, and that's my expertise. I have a lot of experience in that area. I'm a radio guy. So we'll focus on that. And then the back end. That is a presentation unto itself, a topic that will take all day if you want to, because you're talking with computers, cloud services, platforms, analytics, storage, software-defined networks, you name it. There's a lot of technology that's going to be in the back end to give us the analytics and handle the big data, the enormous amounts of data that's going to be generated. And we're going to be looking for information and trying to make sense out of all this stuff. So that's what the back end will do for us. And I'm going to focus on the low power WANs, and then how smart cities are evolving and why they would need this kind of connectivity. And I'll talk a little bit about the Dallas Innovation Alliance and about Light Up North Texas as we get into this. So I want to thank all these companies. Google is awesome, and these people have put a lot of information, these companies, a lot of information out there, and I researched it and cross-eyed sometimes. There's so much stuff out there, but it's very fascinating. Fascinating to me, because my wife did, but that's all right. She's a CPA, so when I can't sleep, I ask her to tell me about accounting. She asked me to tell her about technology. So, the first example of machine-to-machine communications was probably back in the early 1800s. A Russian, Baron Schilling, created what we know now today as the telegraph, but it was very rudimentary at the time. A year or so later, then 2 Germans over a certain distance then communicated with their own code, and then 12 years later, Samuel Morse created the Morse code and started the actual telegraph that we know today. So that's considered the first example of machine-to-machine. And then Nikola Tesla, I think, was a visionary and a very incredible innovator, inventor. And he foresaw, I think, the Internet of Things, machine-to-machine communication as a holistic thing. He envisioned the world being connected wirelessly and basically a brain running all the things that we need to run the world. That sounds like the Internet of Things to me. So a pretty incredible guy, had that kind of vision. So most people know machine-to-machine communications in the old days by the names of like telemetry and SCADA, supervisory control and data acquisition, industrial automation, telematics, communication to cars and things. And we use technologies like wireline and microwave, private radio. The first system I put in from Motorola many, many years ago was a private radio network with mechanical relays at the device, private radio. We went to a translator and into a mainframe. That's how rudimentary things were back then. And then we also had Wi-Fi and satellite are other options. Now, I see machine-to-machine as evolving into the Internet of Things because in the old days, it was focused on one domain, one silo of application. And that data was only used for that particular domain and application that you were trying to work on. The Internet of Things now takes not only this silo, but this silo and this silo, information from many different sources to come in and then analyze it to make sense out of it and give you a better picture of what's going on in the remote side. So that's how I see the difference between the two. So what's happening? We're in exponential times, and the connection of devices, we're probably here at the 5 billion mark with the connected devices. And as you see, we're about to go ballistic, exponential actually. And by certain predictions, Ericsson, Cisco and all, are saying by 2020, which is only 4 years from now, we'll have 50 billion devices. And even if it's 30 or it takes us to 2025, it's still going to be a huge amount, and that's just the beginning. We'll go to trillions eventually. So to be able to connect all that stuff is going to be a real challenge. Now, the Internet of Things is one of those inflection points. Andy Grove talked about it in his book, On the Paranoid Survive, and he talks about Jack Kilby and Robert Noyce created the integrated circuit back in 1958 and changed our world. All our electronics and all the inventions that we have now today are thanks to these guys. They made it possible. So that was an inflection point that changed business, it changed our lives significantly. And then in 1984, the federal government saw fit to dismantle the Bell telephone monopoly, and then innovation took off. And we have cell phones, and we have all the technology that we have today because of that. And then we had personal computers in the 80s. The internet became available to the masses in the 90s. And then Steve Jobs changed the world when he came out with the smartphone, the iPhone, back in 2007. So the Internet of Things is going to become the nervous system of the planet. There is going to be sensors, we're going to be monitoring, controlling, and analyzing everything out there. That's good and that's bad. I choose to focus on the good. I'm going to try to do the right things with this technology and encourage others to do that. So there's going to be a lot of possibilities available. We're going to be able to know what's going on in many different ways, from many different angles, and understand a lot more about our world than we do now. So I broke it down to 3 components, as I said: the devices, the nodes, the remote side equipment. Then you got your connectivity. So those will be coming back to base stations, access points, and gateways are the different terms. Oftentimes use base station kind of radio guy. And then the back end with all the different platforms and computer systems that are back there. And we're going to talk about the networks that are available now, the connectivity issues, or connectivity technologies that are available now. Of course, you've got wireline and microwave, private radio, traditional cellular. So we started off with 2G, which was the first version of the digital communications for cellular, going past the analog stuff, which has all been taken down. So 2G is still out there in some places, but it's being taken down. I'll talk about more of that in a moment. Then we've gone to 3G, LTE, 4G, and 5G is on the planning stage, in the planning stages right now. And then we've got all the short-range technologies: Wi-Fi, mesh, Zigbee, SRD, short-range devices, all that technology, and satellites. Now the problem with those is that cellular is widespread, ubiquitous, but it's expensive. Not only expensive in the cost to put it in and the cost to keep it running and then your cost to pay for that, but it's also expensive in energy use. It's a very complex protocol. 2G was not quite so bad, but it still had a lot of handshake, a lot of chatter going on over the radio network. It chews up their battery. So if you're not on the grid with your remote device, you can run out of battery pretty quickly. Then the other problem with Wi-Fi, the short-range technologies, is they're great for short distances in buildings, maybe in a plant where you can put in multiple access points. But creating a backbone for that and connecting all that is very expensive and a real headache to manage all these small little base stations. So we need something better than that. And then private radio, microwave, the problem with those are they have their place and they will continue to be used. They are used now, but they're not ubiquitous around the world. The frequencies are all different in every country you go to. And then satellite, of course, has great coverage, but it's expensive and it does not have good penetration. At the frequencies that use, penetration is a difficult problem, particularly coming from space into these vaults and buildings where a lot of equipment resides. So low power WANs, low power wide area networks, are a great alternative. And the characteristic of low power WANs, first, they transmit very low power, so they're not using a lot of battery. They don't transmit very often. Because of the frequencies they use, they are optimized for range. And there's a lot of radio techniques they use to be able to get that range, even though they're low power. So by doing that, then they have low power consumption. So you put on a battery. The goal is to be able to run these remote devices over low power wireless networks at least 5 years. The goal is 10 years or longer to be able to not have to go back out to that site. Because a lot of these sensors are going to go into very nasty, hostile, hard to get to areas. And you don't want to keep going back to those things. You want to be able to let that stuff run. So that's the goal for that. Then the structure, the infrastructure that's put into these low power WANs needs to be low cost. And by using free frequencies, which a lot of these low power WAN guys are accessing, ISM, industrial, scientific, and medical frequencies at 915 is the center frequency in the United States, 868 in Europe. Or the Wi-Fi frequencies are actually considered ISM as well. They're remote unlicensed. And then there's a bunch of other small unlicensed segments in the spectrum as well that these low power wide array networks can go into possibly with the right technology. And so by doing that, you don't have to pay for them. The cellular companies pay billions of dollars for the right to have these exclusive use of the frequencies. Good news, bad news. The good is they got exclusive use. The bad news is that's a lot of money they got to get back to pay for that. So the low power WANs have a cost benefit, a cost advantage over the cellular guys. But the system needs to be scalable. It needs to allow the mobile movement of these remote devices. Typically, you're going to put a remote sensing in a static place, but that is not always the case. It may find up moving periodically, or it may be on a moving target all the time. So you need, as a low power WAN system, be able to keep up with those devices as they move around. And then the communications need to be reliable. And that's going to be a real challenge because these unlicensed frequencies that a lot of the guys are working in are very hostile. So you've got to use a lot of technology and techniques to be able to punch through all this other garbage that's in these frequencies.
When you say long range, what do you mean?
A couple of miles at least. Wi-Fi is only good for maybe 100 yards or so. A lot of these short-range technologies are half mile, mile at the most. So you want at least a couple of miles so that you're putting in your antennas and be able to spread them out and get longer than Wi-Fi, but not necessarily 20, 30 miles. Something that we can create a cellular type network for the low power WAN stuff. So low power WANs, Machina, I call it, but it's Machina is what they call it out of Europe, out of London. These guys are good. So if you have any questions, want to do any research, you find your papers by them, read them, because they're very well researched, they're very articulate in their explanations. So I really love them. But they say that they believe machine to machine will be over 50% of all the IoT connections that are in the world. And machine-to-machine communications is very different from our type of communications with our smartphones. Machines typically only need a few bytes of information, and typically just a couple of times a day, maybe, if that most, just periodically, they need to say, here's my status, or something's changed, I need either look at me or come or whatever. So there's not a lot of data for many of these applications. Machina says that, Machina says that short bursts of information periodically is all you need. Does not need to be real time. There can be some latency involved here, as long as it's not half a day. And that long battery life, and it need to be able to penetrate into these buildings, these vaults and things where the equipment's located. And Semtech also did an analysis, and they kind of agreed here the same thing. Cellular is the green on the far left-hand side here. It will have its place. Even though it's complex and expensive, they're coming up with some new technologies which will be low power WAN type communications. I'm going to talk about more of that in a moment because there's some issues with it possibly. Then the short range, the LANs and the Bluetooth technologies will have some applications as well. But the biggest user will be the low power WAN systems. They'll have the most devices connected to it because they'll be the most effective and reach the farthest and have the most cost-effective infrastructure to support that. So I've been watching these guys for 3 years now, and these are the 6 companies and technologies or approaches that have gotten the most publicity and have some legs. They're, I believe, watch these guys. Now, it's the Wild West still. Proving out these approaches is still yet to be determined, because some of these are brand new in that they're only a couple years old as far as being implemented in the world. So I'm going to talk more about each one in detail, but this is very interesting. This is the Wild West. This is a very interesting time for these technologies to be brought to market. So a lot of people have heard about Sigfox. They have done such a great job at marketing and promoting themselves. They've gotten 4 rounds of investment, $150 million on a technology that's a couple of years old. So they've got a great story. They've got a lot of backers, as you see here, Samsung and Telefonica and all. These are big players that are supporting them and hoping that they have the right approach and do well. They are very focused on very short messages and very few communications during a day from those remote devices. So they're going to be a niche. They're going to fill the bill for certain situations where a device only needs to talk once or twice a day. When that device has a problem or issue or needs to report, it will send the message up. And only then will this device see a return message. Otherwise, it's asleep, watching whatever it's responsible for to see if a status change happens or something goes out of range. Something happens here that triggers it. Otherwise, it's only going to communicate only during that time and only listen then for a short period of time after it transmits. So at first it was one way. They said, no, we got to do this reception a little bit. And they added that into 2014. It's a compelling idea. It's getting a lot of background, a lot of support. So they've launched in 10 cities. They're in 8 countries now. Their plan is to go into 60 countries around the world in the next 5 years. So they've got big plans, and we'll see how it works out.
Hey Ed, are those 8 countries mainly Europe and US for now?
Yes, they are. It's out of France.
Yeah.
Sigfox is. And so that's their sphere of influence, and they've got some traction over there. But they do have 10 cities in the United States that they're working within now.
Yeah. Is there any indication as to what other region they're going to? China first, South America?
They're focusing on Europe and then spreading into toward the Middle East and then China as well. China and India and all the Asian is ripe for this stuff, but there's not a lot of activity that I see right now for there. There's a lot of things going behind the scenes that I don't have access to. So I wouldn't be surprised if they announce some major things here in the near future.
So they're gonna build a whole network of cell towers?
Yes. Well, they don't. What's interesting about Sigfox's business model is that they have the technology, they license it, they are looking for partners in these countries. So typically it's a business, already an existing business that has some telecom infrastructure there, typically towers, but it might be the backhaul in these countries. Some company is already ingrained in a country, and Sigfox then sells them equipment and advises them on how to set up the network. So it's a partnership arrangement.
They're like Qualcomm?
Are they like Qualcomm? Yes, in the fact that the inventor of Sigfox still holds all the technology, the IP for that, and then licenses it out. And so he's got his technology pretty much refined for this particular application. So there won't be a lot. Qualcomm, I think of as being constantly evolving. And Sigfox may, but that's not been their focus. They're just going to continue with what they've got now and expand around the world with that particular approach. Now, Ingenue, several years ago, these guys were not considered players. They were very focused on one market, the utility market. And they were based out of San Diego. San Diego Gas and Electric was their big customer. But they wound up putting in 35 networks around the world in an extremely difficult vertical. Utility industries, if you've ever had to deal with them, they are all about security, reliability. You've got to be able to produce, or you don't continue to work with them. They succeeded in 35 different utility and other type of organizations like that for the last 3 years. Actually, since 2008 is when they got started. So they've been around a while. So this last year, some exciting things happened. John Horn was at T-Mobile running their M2M operations, went to Rayco Wireless, built them up, sold them off to Core Technologies, and last year went to the board at OnRamp at the time, and said, guys, I'm leaving, I've taken Rayco to a buyout situation, and I'm moving on to the next thing. You guys have a technology I've been watching, and a bunch of old Qualcomm guys started OnRamp. And you guys, I want to take you to the next level. And the board said, with your this history and background, and then he explained his view, he said, we'll do it. So they changed the name to Ingenue. They now are focused on creating a network all across the United States. They're going to put in, I'll talk about that in a second, but they're using the 2.4 frequencies, which a lot of people say anything below 1 gigahertz is good because it penetrates deep into these buildings. With their focus on 2.4 and their ability to manage the radio signal, and they call it spreading, they use different radio techniques so that they can get the message into these buildings and into these vaults and things. When they finally do, then they get acknowledgement, and they know that's the right protocol to take to get to that device. So they've got that kind of thing worked out. They've got security worked out. They've got this history now since 2008 of being successful in putting in these systems, and they've got great coverage with their system. So it's something to watch. They have these 35 networks around the world. They sold those private networks off to Trilliant, taking that cash flow now so that they'll be able to put in the machine networks, what they're going to call it. It's dedicated to machine-to-machine communication, Internet of Things, in 30 cities in the United States and by the end of 2016. And the first 2 cities they're going to put it in is Phoenix and Dallas. I talked to them. They're going to be coming to Dallas and they're here now. They're going to be turning it up at the end of March, end of the first quarter this year. So it's going to be very interesting to see how well they build their ecosystem, how well they're planned, and how well they work in this environment here in North Texas. Then they'll roll out the rest of the United States after that and then go international. And they've already taken the guy that's been responsible for rolling out the United States and moved him to international so he can start working that plan. So very exciting. This is on their website. Extremely, a lot of coverage that they can cover with their cell sites. So very interesting. These guys are getting a lot of publicity. So they've got a different approach. Now they're more robust in the amount of information that they send. So LoRa was created by Semtech. Semtech is a chip manufacturer out of Silicon Valley. LoRa stands for Long Range Communications, or Long Range Wide Area Networks. And LoRa Alliance is what they've created to help them promote this and get their ecosystem built up. Now their system is open above the physical layer in the stack. But the physical layer, Semtech holds that. So you've got to license their technology to be able to build devices using the LoRa technology. So some people are saying that's not such a good thing, but that's their way they're going to make money out of it. So it's a thing to consider. They're getting a lot of traction, and a lot of countries are looking, a lot of people and businesses are looking to put systems in the countries. Now, they're robust because they are spread spectrum. They have 3 classes for the remote devices. Class A is much like Sigfox in that the device, when it has something go on, then it transmits and then it listens for a response. If it doesn't get a response, it transmits again, that kind of thing. Very good long battery life, very good for certain applications. Then you move up to Class B. These devices then transmit when they need to, but they also periodically listen to see if the base station, the access point, has something to send to them, so that they're not as energy efficient. But in some applications, you need to be able to periodically talk to that device, and you want it to be able to wake up periodically when it's on and listen. In Class C, the device is constantly listening all the time, and the only time it transmits is when something happens at its site, what it's responsible for, or something changes. And they've got to transmit it up. So then it turns off the receiver and then transmits up and it goes back to receive mode. So very interesting. They thought a lot about this, so they put together a pretty robust system. Now, all of these systems are like cellular systems in the topology. These are frequencies typically, but the topology, where the antennas and how they talk are set up. So if you go to the left-hand side, those are the remote devices, the nodes, whatever, out at in the environment. They talk back into an access point, gateway, or base station, whatever you want to call it. They call it gateway here. And then it goes back into servers, which is talking to all these other different access points. And then you got your cloud or your network or your computer, whatever is on the back end handling that. This is looking down at the top, so this would be your computer system, your cloud or whatever back here. Then you got your backhaul to your tower sites, and then from your tower sites to access points at the tower sites, then you got your different remote sites. So that's how a star of star technology works. And all of these systems operate that way. Now these guys, this is exciting, because we have the CEO, COO and CFO of InWave in the United States right here with us today. Paul Peck, where are you, Paul? Paul runs the InWave operations here in the United States for InWave. This got started, when I did my presentation 3 years ago at the IEEE, it was about Weightless W, which we didn't know it was W at the time. W stands for TV white space. TV white space transmits on unused frequencies in the TV spectrum. So if somebody's transmitting on 21 and 23 in Dallas, 22 is open because there's nobody over there. You can, by the FCC rules, transmit if you keep your power down low and your antenna at a certain height, you can transmit on that. Well, the United States and the UK are the only ones that approve that. So that's been put on the shelf. InWave has this technology, and they came to the Weightless group and said, look, we'd like to offer this IP up so it can be royalty-free, used by many people, so they can produce the equipment. And so it was approved last year, and it is bidirectional. It transmits ultra-narrowband, and it has great applications for those situations where you need just a little bit of data when a thing changes at that roadside. So one of the things that they're really focused on is parking, smart parking, and counting cars, the kinds of things where you just need a little bit of data periodically on what's going on. Tremendous payback, a very efficient way to run a city when you've got restricted parking. So they're working on several different projects. Anything else you guys are working on that you want to talk about for a moment? Okay. So, but
I want to slow you down here.
yeah. So, but Paul's an excellent guy to know, and a lot of good things that they're doing. So, the other standard for Weightless that just came out, this is more like the LoRa standard. It's more robust. It transmits more information. It may not be as energy efficient, but it's not been in the field yet under the standard. It just got approved late last year, early this year, and so it's to be proven out. But the potential is there. The great thing about the Weightless standards are that they're royalty free. So if you join the organization to keep them sustained and so they can do their job, then building equipment is royalty free. You don't have to keep paying for every device that you manufacture. And you can use the stack and be able to use the protocol with no problems. So M2Com or M2Com is the ones that donated the IP to the organization. They're out of Taiwan. Their technology, the products they've been producing for several years have used this. Very, very good, very efficient, and very well thought of in the industry. We need to see if it can be adopted and spread worldwide. And so we're in that stage where it's early on, early development, or early implementation. These guys are the ones to watch. This is the big elephant in the room. This is the cellular version of low power WANs. So traditional cellular is 2G, 3G, 4G, LTE, and 5G eventually. That's not a very good application for machine-to-machine. It's great for our smartphones because that approach is going toward more and more bandwidth, higher data rates for our devices. Machines only need typically just a little bit of information. So what they're doing now, Ericsson, Nokia, and Intel came to the 3GPP standards group for the cellular industry, representing about 900 different entities around the world. And they said, look, we've got an approach to low power WAN that can go integrated, that can be integrated into the LTE networks that are out there right now. It is based on the idea of using their 200 megahertz wide LTE resource blocks in the transmissions that are sent out, which will go then to the remote devices. So short messages interweaved with existing equipment, existing technology, existing infrastructure. A great idea. So they adopted it as a work item late last year in September. It's being worked on right now as a final standard to be released as part of release 13 of the 3GPP. Problem is, this is like a camel being built by a committee. It may turn out to be great. It may turn out to have all kinds of issues because there's all these people representing the standards body may have input and change things. We'll have to wait and see. The other issue is that it's going to take time for this to get standardized, to get tested, and then to get implemented. So we're looking at 2 to 3 years before it truly gets in the market. They may try some early beta systems and some early adoption of it. We'll have to wait and see. The other thing is there's a couple other competing approaches that are being considered as well, and it's confusing to the carriers. They may adopt something and not this. So they may have some of people using this and some people using something else. And if you're an international company trying to go different places, you as a consumer or the business may have trouble operating in certain countries because you chose this technology and this carrier and then you can't work with it. So it's that kind of thing. It's going to be interesting to see how it works out. But if they get it worked out, all these companies right now are supporting it, and this is just the short list. There's a longer list of companies that are on board with it. So it has the support of the cellular industry. We'll just have to wait to see if they are able to implement it in a cohesive and comprehensive way. So that brings us to smart cities. Smart cities. When I started looking at this, I was blown away. I thought Internet of Things was going to be big. When I just looked at this one segment of smart cities, I was amazed at all the different initiatives, all the different countries and cities that are getting involved, and all the money that's going to be spent on this, just on smart cities. And we're not talking about smart grid and smart all these other things, smart cars and smart homes, everything. This is just one segment. So the definition, there's over a dozen definitions. If you try to look it up, everybody has their different way. This is the one I chose because it's pretty comprehensive and a good overview of what it is to be a smart city. So it uses information and communications technologies, ICT, and it enhances the quality performance so that your urban services are better distributed and provided to your customers. You're able to respond to challenges much easier. Then you're able to reduce your costs, particularly your energy costs, which 40% of a city's money is spent on lighting. So if you're able to reduce that, then it's a very attractive technology to apply. And then you want to improve that relationship between you and your citizens. You don't want them moving to another city because you can't satisfy their needs or requirements there. So pretty good definition. So why smart cities? In the world right now, 50% of the people are in the country and 50% in cities. That's changing, and in the next 10 years, it will be 60 to 70% around the world will be in the cities. We're already there in the Western world, the industrial world. We're already at 8% of people living in the cities. Well, that puts a strain on the cities. The cities have restricted budgets, and so their resources are challenged to be able to respond and take care of. As you see, the big cities have real problems, and so they are looking for answers. They need some way to be able to monitor, control, analyze what's going on, and make proper responses. And that's where the Internet of Things will help. And because so many devices are going to be out there and the existing technologies are limited, if you were to use the existing connectivity options that we have available, Wi-Fi and cellular and whatnot, that would only satisfy 1/4 of the requirements for connections in the next 5 years. So we've got to come up with something else. That's why LPWANs will be so important to cities. So Frost and Sullivan has some great reports as well. They define a smart city as having 5 of these approaches, concepts, characteristics, however you want to characterize these things. So if you've got smart governance, healthcare, buildings, mobility, if you're applying your IoT technologies to these things, infrastructure, your technology, energy, and your citizens, if you're doing 5 of those, then you're considered a smart city. Well, it turns out that there's not that many now, but there's a lot of people beginning to apply these technologies and try to find out how they can. In the past year, they've been working on applications, domains, just 1 or 2 domains. And now they're beginning to realize they need to create platforms and frameworks which then can allow all these different applications to be accessed and supported off of this framework, this platform. So these are examples of cities that are doing this now. It's still early on, so there's a lot of trial and error. There is no standard way to implement a smart city. Nobody agrees as to what it is. It depends on where you are, what your situation is, how big you are, what your problems are, the challenges that you face. So Europe, it tends to be a more comprehensive, wider view of what they're trying to do. Here in the States, we're more on, let's figure solutions to these kind of problems. So it's a little different attitude and focus on what they're doing. And I'll go into some of these here. Barcelona was rated #1 as far as a smart city by Juniper Research recently. They've been doing this since 2011, so they've been trying different things with their Internet of Things. And that's what they came to, is that they needed to create a platform. So they call it City Protocol. And with that, they're able to do the sustainability and create better economics in their area to help them be competitive in the world against other countries and cities, whatnot. So they said it's quite interesting. Most people didn't notice it because a lot of the things they're installing are kind of behind the scenes. But if you start looking closely, you'll start seeing things embedded in the parking lots for parking, car parking. You look at the lights, and there's a ball up there, and you go, what's that? Well, it's a pod of all kinds of electronics. It's measuring weather and temperature and people that are in the area. It will eventually provide Wi-Fi. All sorts of things are going to be put in all these different little pods, if you will, on the lights around them. And it's helping to bring information back into the city so they can do, they have the data so different applications can be created on this platform we've got. Same thing in Amsterdam. They've actually been doing this since 2009. They also came up with the idea, it's got to be a platform, so they call theirs Amsterdam Smart City. And just recently they announced that they have a lot of boats over there in their canals and whatnot that develop leaks, and if you let it go too long, you have major problems. And so they used their network over there to create, well, the citizens did this, they used their access, created a monitoring system, so if a boat develops a leak, it immediately sends off a notice to the owner so he can go and quickly get it repaired before it sinks. So there's all those sorts of things. What they've done is created a formal channel so they can catalyze, they can accelerate, and then fund and implement these opportunities, applications to find solutions to the problems.
Ed, real quick,
Yeah.
are they doing most of those through public-private partnerships, like we saw in Kansas City with Cisco? And
Yep, exactly.
okay.
Yeah, they're big about that. In Europe, they're really, they're more socialistic than we are, and they're really good on trying to put together businesses and governments. It's a tripod. So you got your governments, you got your businesses, and you got the citizens. If you got all three of those working together, then you can come up with solutions, and that's their philosophy. And I think that's what many people that are putting these smart city systems in are realizing. They've got to find ways to work together. So in New York City, they're doing something of the same thing. Again, they're focused on just certain applications and whatnot. And this intelligent living, Hudson Yards is a development, and so it's a comprehensive set of sensors in this region to be able to monitor what's going on there. It's kind of a test bed for them to show what they can do, refine it, and then improve its capabilities of providing services to the citizens. And they're going to put Wi-Fi in everywhere. All 5 boroughs, they're going to put Wi-Fi in. So they've got some big plans there. And they do smart buses, being able to manage the routes better. They're actually watching the gunshots and be able to triangulate them. So they'll be able to know where things are going wrong, but they need to send the police and focus on those areas. And then neighborhoods, interesting, they're going to put, each neighborhood will have its own URL. And that neighborhood then, the citizens will have access, share information with their neighbors, and keep up with what's going on in their local neighborhood. They're going to support that sort of thing through their platform. Very interesting. I wish them well, because some of those ideas may catch on. And the nice thing about these cities doing these things early on is we all get to watch and then learn. So we'll be able to implement quicker on our end. Samdo, South Korea, they created a business district from scratch. And they put in all these sensors and everything to create the ability to efficiently manage and monitor and keep up with what's going on in that area. And it's a very progressive. You can read more about these things. I've got some links at the back, or you just do Google search on these things. Quite interesting to see the breadth of the tests that are going on, or the test beds that are going on, testing. India and China. India, Narendra Modi announced here recently that they're going to upgrade or install in 100 cities the smart technologies it's going to take to make those cities smart cities. And that may cost them $1 trillion, but I have no doubt that they will do something that will blow us away. On their budget stream, they went to Mars. They can do incredible things on planet Earth. So we'll have to watch them closely. China just announced their 13th 5-year plan. And the big thing, I had to look and look and look before I finally found it, because everybody's talking about their 12th one that they came out with. Well, it ended in 2015. And so I found this one. And the key part about this, they're so early in the game, they're so huge, they got so many things they have to deal with. They're not for sure exactly what they're going to do. I mean, they got all these different strategies and goals and plans. We'll wait to see. But the key thing that I took away is they're going to spend a heck of a lot of money in the next 10 years. So it's going to be a real challenge for businesses to work in China. Yes?
This is Ram Dant from University of North Texas. What are the 3 things cities spend the most? For example, healthcare, transportation, education. Maybe I'm just asking. A lot of people know what this one.
Yeah, what I read and what I saw is energy. Wasted energy, or the use of energy in their lighting and other buildings and things that the city is responsible for, is just eating them alive. And then you've got all your other services. So if you can find a way to become more efficient in your energy, so one of the ideas is that you only turn on the lights when you sense people walking down that path. And you look for water leaks, and you only empty the garbage cans when they're full. So you put sensors, that kind of thing. Wherever you can find ways to efficiently manage your services, you're going to save a lot of money, just off the bat.
Just curious, what is the percentage money that they spend on energy? Like 50%, 60%?
40% is what I heard.
Right.
40% is spent by the average city on electricity for all of their lighting and everything that they have to run. So a lot of money is going to be spent around the world in all these different cities and all these different countries. Now the challenge for government officials is they know something's got to happen. That things are happening out there. They need to become more aware. They need to become more educated. That's the first thing they got to do, is learn how they can take advantage of these technologies. The second thing is they got to figure out which technologies to use. There's so much variation in what the technologies can do, and depending on what their needs are versus what they want to try to do, they got to figure out what makes sense for them. And then the third thing is they got to figure out how to harness the social media, the crowd sourcing, and the sharing economy that's developing. How can that be used to help them manage their cities and their citizens better? So lots of interesting dynamics going on right now and decisions that have to be made. So there's going to be a lot of money spent here in the next 10 years, $1.7 trillion for the world as far as putting in IoT solutions and services and different ways of doing things. So there's 4 different ways to play as a business person in this game. So you can be an integrator and provide things from end to end for your customers, for your cities. You can be the network operator, so the M2M, the cellular guys will provide that connectivity issue. Then you've got the product vendors who've got hardware and assets that they'll be able to provide for these solutions. And then you've got managed service providers. So they'll be the third parties that will handle all of a city's operations, oversee them, manage everything that goes on there. So it's a third party, it's a handoff, it's a contract sort of thing that the city will take for these things. So different ways that businesses can participate in this deal.
Ed, are you seeing cities are already starting to competitively bid for these vendors, or do you have to sometimes partake in the public-private partnership like AT&T in Dallas or Verizon in New York?
What's happening, and I'll talk about that more in a moment, it's a good lead into it, but yeah, we're early on. There's not a lot of, that I see so far, a lot of bidding for companies to come in and do these sorts of things. There's a lot of test beds and initiatives going on. So let me show you that, what happened. This is a great, if you go out on the web and look at it, this goes into more detail about those 4 ways that business people can participate in the rollout of Internet of Things. So this is about the U.S. government. So we've got all these other initiatives around the world, some going on since 2009, 2011 and whatnot. September 14th of this last year, the White House came out and said, we're going to do smart cities. And we're going to put $160 million into 25 different technology collaborations. And we're going to do it in 20 cities around the United States. So it's a 33-page document with links out to 24 different things. So there's a lot of planning, a lot of possibilities coming up. And there's going to be a lot of money spent on trying to help the United States and our local governments start working towards solutions for their cities, much like what's been going on for several years elsewhere. So their initiatives are pointing cities toward reducing their traffic, fighting their crime, improving their economic situation in their cities and their local areas, and then how can they manage the effects of climate change? We've seen such dramatic changes in our weather in the last few years. Being prepared for that, 27 inches of snow in New York City, I feel for those guys, but I'm sure glad I live in Dallas. And so that kind of thing is going to be affecting more and more people around the world. And then how do we deliver city services more efficiently? So those kind of the key. Well, Dallas is one of those 20 cities that's been chosen to be on this in this program. So we've got several things going on here. The Dallas Innovation Alliance is putting together, or has a 3-pronged approach to installing the first version of their smart city, a test bed. They're going to do it in the West End, the historic area down there. And that's because it has a lot of infrastructure already in place for the existing businesses, and it's a good combination of businesses and people living down there. And so there's a lot of mobility, not only cars, but mass transit and then pedestrians in the area. So how can you better manage all that sort of stuff? And then how do you make their lives easier? How can you connect them so that they're able to interact and get their services and communicate with the government better? So AT&T announced that it seemed like they were kind of leading the charge on this thing, but they're only one of 13 members in there. So you got AT&T, IBM, and Microsoft, downtown Dallas, and the city of Dallas that are mentioned in the press releases that I could find and information that was out there. So there's a lot of big companies supporting this. Almost done. So the other thing that's going on is the city of Dallas is working with the Texas Research Alliance. This was created, the TRA, back about 5 years ago. I think Bill Spruill was behind getting it organized and whatnot. The Texas Research Alliance is comprised of the presidents of the Chamber of Commerce for Dallas, Fort Worth, Arlington, and Richardson. Their goal, the TRA, is to work with the 6 major universities that we have here in the area and help them help us. And so that's UTD, UTA, UNT, TCU, SMU, and then the UNT Health Science Center are all part of the TRA. So that combined with Dallas, we've got those projects that they're working on. Early stage, not a lot of definition yet, a lot of information available, but things are beginning to move toward that, toward those kinds of projects.
I missed the question before the slide about the 4 different things that people can participate. This one. What do you think the small business, where they can actually fit into this?
There'll be places to play for everybody eventually. Right now, the big guys are the ones driving mindset and influencing cities on the direction. So if you're a small business, you may be fighting uphill, upwind, however you want to say it, until the direction is set. So if you've got, though, a device, for instance, networks are going to come online here shortly. The Ingenue RPMA network, InWave's network. They're going to be, and Laura's going to come in with a network before long. So you may be able, and this would be a challenge, but maybe the best way for small businesses to get on some of these networks and provide their solutions, the back end, the software applications that they have available that can go through the network then and control the device or monitor handle some remote site, or create the device that goes out at the remote site. So I know several people that are working on devices that will be able to connect to these different networks and do the kinds of things we're talking about, be a very universal type of device to handle things. So there's going to be different places to play. It's early in the game, so it's going to be hard to direct people exactly where to go. So the last thing here is Light Up North Texas. So part of the telecom or Tech Titans IoT Forum challenge, or what we are going to do, is we're looking to other small cities, not Dallas, because they've already got their project off the ground, but we're approaching and targeting other cities here in the Metroplex, particularly Plano and Allen and Frisco and Carrollton and Farber Branch, and maybe Irving and Arlington and whatnot, to be a part of our Light Up North Texas. So we want to start doing our own testing, our own test bed, our own projects as well, to start proving out these smart city approaches and to see what works for us here in the North Texas area. And if you are interested at all, come join us and be a part of that. We'd like to get as many brains working on this and as much support as we can get to help us move this forward. So with that, these are the links. I'll make this presentation available. You can, if you like, I'll post these on my Google Drive, and I'll leave my cards here. You're welcome to reach out to me. I'll be glad to send it to you. I will also, I'm recording it if it worked out. Is it still working back there, Mark? So good. So I'll edit it the next few days, and then I'll add the slides onto the audio part of it, and I'll post it, so it'll be on the Tech Titan site, it'll be on my LinkedIn profile, and another place or two out there. So you can review this and forward it to other people so they can watch it as well. So any questions or answers that, anything else that I can talk about?
So,
I'm sorry, let me go this way. Kim?
On your NB LTE, are there any carriers that are actually selling bandwidth at this
No,
point?
not yet. So Neil, maybe I'll say answer that, but there, okay, so no. It just got sent to, but there's going to be some test cases to be done before the end of the year. So there's plans to try it out, I think with AT&T here shortly. I was reading that Ericsson is working with AT&T to implement that. Verizon also has a version that they may be trying out here shortly. Again, not for sure if that's the approach that the 3GPP people are going to, because they haven't finished their spec yet, so nobody knows exactly what it's going to be. So I don't know what AT&T and Verizon are actually going to test, but it may be something close. But we're looking at another years before the actually widespread deployment. Raj? I'm volunteering.
So Ed, I'd probably have said this before the presentation started. So security and privacy, a couple of things that will come after, right? I know this is not the topic of the
no, it's important.
But I have to say this because I'm the global co-chair for cybersecurity for Cloud Security Alliance, and this is one of the biggest efforts and initiatives that we have across the globe. And all of that you mentioned are there. But I think this is one, just because we are saying that we're going to go and put Dallas on the map, IoT map and smart cities map, and I think this is something we should consider, right? Cybersecurity and privacy would come. Not like what we did with network and internet, right? Security was an afterthought, but with IoT we cannot miss that boat.
A very good point. That's one of those things, I'm focusing on the positive, but we do need to put in more security, better security, right from the very beginning, or we're going to have tremendous headaches with all the information that's going to be available about us and our activities and the things that we're involved in.
I just have a question about if you could comment on the coming impact of programmable optical data networks in the context of today's discussion.
Programmable optical data networks.
Yeah.
So, I'm not for sure exactly what you're driving at, and you may want to comment yourself, but I know that fiber optic, the great thing about fiber optic is that it is very easily changed because you can keep the glass in the ground and change your transmitters as technology improves and increase capacity. And you can start using other wavelengths besides the standard wavelengths you started out with to add capacity to that. So those are the kinds of things. Is that what you're getting at?
Yes.
Yeah, there's a, we've talked about it because that's the back end I talk about.
Yeah.
You know, you have your devices, you got connectivity. This back end is so involved, complex, so many different pieces of it. I could spend all day talking about that. And one of the things he's referring to with this optical stuff, that's part of the data network that exists out there. Our present experts are going to get crushed. We've got to come up with ways to handle all this influx of data that's going to be coming in. The wireless stuff is going to have this challenge. But when you start dumping it into the network, the way we've got things set up right now, they're very much fixed. It's like hard code, and you can't change things around. So they're moving to SDN and FNV, software-defined networks, and network functional virtualization. Did I get it right?
Yeah, NFV.
The idea is that you change your networks to being proprietary and hard-coded to being programmable, so that when your information comes in and one area has a lot more than someplace else, you change your resources to be able to handle this influx of data here and pass it through. And there's many layers here. You got hardware, you got software. It's basically like a computer system. You'll have your hardware, your hard drive, and your computer processing down here. You'll have your firmware that basically manages and talks to this stuff, and it talks up to the applications that sit on top. That's where they want to move to with the network, and it ain't there yet. So they got a lot of work to do. But Ericsson and all the other telecom manufacturers are working on the SDN part, and then equipment manufacturers are working on the NFV, network function virtualization. So the device, make the devices able to talk up. So lots of stuff are going to happen here shortly, and hang on to your hats. We've got 5 minutes, and yeah.
Ed, I have one.
Leroy, okay, let me do Leroy then.
Leroy Levine. Ed, you had mentioned the Dallas Innovation Alliance briefly. Does anybody here have any information as to what they're currently doing, what their current status is? Their website hasn't been updated for some time.
I had coffee with Jennifer Sanders. They've divided into working groups now, and they don't have funding yet. There's a lot of governance and things like that that have to be decided before they can kind of move forward. So they're doing a lot of organization right now. There'll be another meeting in February. I'm going to attend that meeting, and then after that, I think they're going to come out with more of a plan.
So they're not yet open to public meetings, sort of thing.
Right.
At this point.
But they're getting organized, and
Okay.
lots of people have signed up.
Thanks.
And you had a question?
Yeah, so I'm Mohit Nagam from Harman International, which is part of the Harman Kardon grant. So about the technologies that you mentioned, Sigfox and others, do you think who has a better runway of making it successful from a cost efficient?
InWave has some inroads for certain applications, so they'll talk to Paul about where he would fit. The other one I'm really excited about, quite frankly, is Ingenue. Wow, I talk a lot. And their RPA network, because they're coming to Dallas the end of March, end of this quarter, and they're going to turn up a network. And I talked to them about it, and it's going to go from Mesquite to McKinney to the east side of Weatherford. I don't know how far south, Waxahachie south. And their technology will cover all this area reliably. Now, it's to be seen and proven to me how well they penetrate into buildings and places where devices are located deep in buildings. But they have the various radio technologies, techniques that they're going to spreading and whatnot to help the signal get in, and it's two-way. So they keep trying. They change the protocol and they keep trying until they finally get in and talk to that device. And then they keep using that to talk. And it's highly scalable. The good thing about their technology also is that many of these other technologies, you keep adding tower sites like they do with cellular, but it doesn't help them. Their approach, though, it does, because it tends, you can make your cells smaller, but more dense, so you can handle more equipment in these areas. So they're already set up to do that sort of thing. So anyway, I watch these guys and stay tuned, because when they come into the area, I think they're going to make a lot of waves, because they're going to be alternative to cellular, and they've got a track record and technology that's been proven out.
Are any of these guys integrated with like Zigbee mesh or anything like that?
None of these guys, but Google and some other people are trying to create a backbone to connect all the Wi-Fi short-range technologies together. It'll take somebody like a Google to be able to do that because it's a very complex management issue when you start taking on all these little islands of connectivity. You got to be able to put it all together and have a backhaul, backbone that can handle that kind of stuff, and then manage them and keep up with what's going on. It will probably happen. Anybody can do it. Google will, or somebody like them will be able to handle that. But it's not helpful when you've got oil rigs out in West Texas or off the shore or whatnot, unless you're able to put
You can tie your oil wells together and then have one cell modem or whatever.
Yeah, so, yeah, there's several different approaches. It's going to depend on, do you have the money? Is the technology mature? Can it be used for that particular application? That's the exciting part because we've got a building block, set of building, we've got tools and a chance to build things that have never been able to be built before. And so, you've got problems, we need to figure out what the solutions are to be able to solve those problems. And that's innovation. And that's what we're good at. A guy, I'll close with this then. A friend of mine, acquaintance and a friend now, out of Austin, worked with DARPA, works on projects for connecting legacy equipment to the Internet of Things. He's talking to his people down there in Austin, and they get the programming part and whatnot, but they don't get the Internet of Things. They don't understand about all this connectivity, communications and whatnot. He comes up here and he speaks 2 months ago on a panel that I moderated, and after he got all the questions and all the interaction with the people that were there that understood and talked to him about Internet of Things, Pete Donaghy is a great guy to get involved to talk to people. This guy, Mike, he said, I'm moving some of my operations up here because Dallas, the telecom corridor, you guys get it. You understand. You came out of the communications world. Telecommunications is your history and your blood. We only do software and chips down here. We don't hardly can spell IoT. So, so he's moving up here, moving some of his operation up here. So I think that's what we're trying to do. I call this telecom corridor IoT Central. This is where we want people to come now. We got the resources, we got talent, we got people, we got ideas, and we got entrepreneurs that are willing to put themselves out there and try things. We can be a leader in this in the United States. I love